All right, the topic is a phase change graph. And right now you should have kind of a loosely sketched graph in your journal. We're not going to be plotting points or anything like that. We're just going to basically look at trends when you heat a solid like ice. So what we need to do is we need to label our x and y axis. And down here on the x-axis, move that up if it lets me. Will it let me? Cool, it will. Down here on the x-axis, we're going to go ahead and label this time heated. We're not going to put a unit or anything like that because it's just a conceptual graph. So we're just going to say time heated. So this goes from 0 to however long you heat something. For you guys, you heat it for about 25 minutes or so. Up the side, we're going to put temperature. And it doesn't matter the units and stuff like that because, again, it's just conceptual. So we got temperature going up the side. Let me just put an arrow to show that it's going up. And heated time is going up this way also. All right, so here's the plan. I'm going to need some participation here looking at the data that you have. All of you started at -5. The ice that I gave you was -5 degrees Celsius, and that's where we ended up having it. And for all of you, once you put it in the beaker on the burner, that ice started to heat. But then what happened? It started like right when you put it in, it started to heat, but then what happened?
It kind of stayed the same for a while.
Yeah, it leveled off. And as I look at all of the graphs that you did during the lab, they all leveled off. Maybe they didn't level off like this, but they leveled off and kind of like hung around the same temperature for a while. Does anybody quickly want to explain what was going on during that time? Why did it level off? Can you put that in your own words as to why that temperature did not go up? You were heating ice, you were adding heat to it, but the temperature wasn't going up. Why is that?
Because the ice cube was slowly melting, so like the temperature couldn't change.
Temperature couldn't change because it was melting. And do you notice that the ice stayed that temperature until it melted? Then once it melted, it started to change. All of you saw that on your graph. Ice can exist under normal conditions. Ice can exist above that 0 degree mark or so. 0 degrees is the melting point and the freezing point for water. So at 0 degrees Celsius, that's when that ice is going to start melting. So a good way to look at it is this curved line here, or the little slanted line, is ice. That's your ice. Then that temperature of the ice will rise until it starts melting, and then it will level off. So what happened after your ice was done melting? What did you observe? Either with temperature or what did you see? What did you see?
The temperature rose.
Temperature rose. And did you notice it, once it started to rise, it rose pretty quickly? Or it like shot right out of there. So all of a sudden your graph kind of looks like this. By the way, you no longer had ice at that point. You notice your ice was all gone at that point? So we're not going to call it ice anymore. We can call it water. And we can call it liquid water would probably be the best because ice would be frozen water. So we're going to go ahead and call it liquid. So we're going to stick liquid there. And then down here, I suppose we could call ice solid water. That sounds cool. I feel bad for kids who are like, solid water? Awesome. How do you have something? You just freeze it. You put it in the freezer and it becomes an ice cube, which is solid. So here we go. At this point, we got melting going on. Once the melting is done, then we've got liquid water. All right, how about you guys take it from here? What happened next? Something else happened. It just didn't keep heating and heating and heating and heating. Something started to happen to it. Something started to happen to the temperature change. And what started happening? What did you notice?
It leveled out a little again.
Notice it leveled off again. About what temperature did that happen? Just curious. About what? About what? 98 for you guys. What level off after you?
99.
About 99 or so. Anybody have something different? Right? 98s, 99s? Great. Once water approaches, and if we take a look over here, we got 0. Once water approaches about 100 degrees Celsius, depending on the accuracy of your thermometers, if there's anything dissolved in the water and stuff like that, at that point, it's going to level off. Just like melting was taking place at the last point where it leveled off, what's taking place now? There's a process taking place that doesn't allow it to raise its temperature because something's going on. Not melting, but what?
Turning into gas.
It's turning into gas. Cool. What's the process when it turns into gas? I'm just curious. Process. Jason, what? You can use the word evaporation. You can say it was evaporating. What else could you say? If you were cooking, what would you say the water was doing? Maybe you could say boiling. And for water, it's about 100 degrees Celsius, okay? So that's where our evaporation or boiling point is going to be. Now, take it to the next level. Just like we had to wait until melting was done, then we were able to raise that temperature. What do you think would happen if we allowed boiling to complete and all we had in there was gas? What do you think we could then do to the gas? What do you think?
And the gas would start to after it was would start to cool down and all the water would
That's if we let it cool, but what if we kept heating it? Notice after, you would say that it would condense, which is the last thing we're going to talk about. So we can take that solid and we can melt it into a liquid. Then we can get it boiling. What do you think, looking at that pattern, would happen next once it's done boiling? What could you do? Pass it?
The heat would rise.
Yeah, then all of a sudden the heat could start going up again as you heated that gas. So right here, this is a heating curve of that's what it looks like. You can take a solid, by the way, the solid doesn't need to be ice, which we'll talk about in a moment. We can take a solid ice, we can heat it to its melting point, it will hang out there until it's all melted, then the temperature will shoot up again, it will hang out there until it's done boiling or evaporating. Then at this point, you could heat that gas, and you could heat that gas, or we could say steam in this situation. We could heat that gas all the way until it would heat the next phase of matter, which is called the plasma state, which you'd have to go thousands and thousands of degrees, which we don't need to worry about. So this little shape here is called our heating curve, or our phase change graph, and it's very similar to what you made in the lab, and you guys just came up with it kind of on your own, which is kind of cool. All right, it happens with everything. Rocks. A rock. A rock is solid, unless you heat it. Then you can make a liquid rock. Now some of you are like, what? You can make a liquid rock?
Yeah.
You already know that. Where's a really hot place where you can put rocks and they become liquid? What? Volcano. Volcanoes are heated rocks. So if you have a volcano under the ground, you got magma, comes out, it's lava. You probably learned this before. So rocks at a cool temperature are solid. They'll hold their temperature as they melt. Now it doesn't happen at 0 degrees. It happens at thousands of degrees, but it's the same thing. You can take rocks, which are solid, heat them, they will melt. They can turn into a liquid. Then you can heat that liquid, magma in that situation, and then it would start boiling, which is crazy, till those rocks could turn into gas, which is crazy. Now, it doesn't get hot enough on Earth for stuff like that to happen readily, but if you were to take a rock and throw it at the sun, it will go through all of its phases of matter. It even happens with things like air, which is weird, like oxygen. Oxygen is a gas right now in the room. Oxygen is one of the gases that you're breathing in, carbon dioxide, stuff like that. If you take oxygen, which is a gas, and you cool it, you can get it to condense into a liquid. In fact, if you've ever seen a scuba tank that has oxygen in it, or been on a fire truck where they have O2 in canisters, you ever seen that in movies when they put the little mask over people when they get down and they get in the ambulance? If you shake that tank, it's actually liquid oxygen in there because it's been cooled or compressed or something like that. You could actually cool oxygen so much you could have solid oxygen. That is cool. Kids are like, there's no such thing as solid oxygen. Sure, you know where they use it? They use it someplace really awesome. On the space shuttle, you remember the space shuttle?
Yeah.
You remember the orange tank in the middle, fuel tank? And you had those white rockets on the side? Those white rockets are super cold, and they're filled with liquid oxygen. I'm sorry, with solid oxygen. Okay, they're called the SRBs, or basically the solid oxygen rocket boosters on the side. Okay, and they're filled with solid oxygen. If you went out and touched them, you'd freeze your hand black with frostbite. When you watch it take off, you can see chunks of ice fall off it because they pack it with solid oxygen. So what do you need to realize? Absolutely, or at least most things can go through these phase changes as you heat them. Solid will melt into a liquid, which can evaporate or boil into a gas. You can also go backwards. If you know that, you guys are in good shape.
What about a person?
Cool. See ya. Bye.
Look, what